It's a pleasure to be with you here today to hear from a variety of different experts focused on engineering for global development, youth-inspired solutions to water energy nexus challenges. And I think it's easiest to describe and think about the event if we break it down into three constituent parts, that exact title. So engineering for global development, that's the first part of that title. So this is an engineering-focused conversation that's driven by the need or the interest to have global impact. The second section is youth-inspired solutions. Arizona State purports youth-inspired solutions is one of our major tenets of the university, as well as the many collaborators we have and excellent researchers in the field. And so that youth-inspired solution is what is providing clean water, clean energy, very specific driven needs, such as the NAE's grand challenges of engineering. You also have water energy nexus challenges. So we're not just talking about engineering for global solutions that are driven by actual human needs, but they combine at least two different facets of engineering in terms of energy and water, and undoubtedly, as you'll hear today, a deep appreciation for local needs, cultural context, economics, policy, culture, etc. Some of the needs around the world that you'll be hearing about. So there's 1.3 billion people without access to electricity, 900 million people without access to clean water, 2.5 billion people without access to clean sanitation, and this is being addressed through much funded work, development work, USAID, United States, UK's Department for International Development, and other international agencies focusing on the development side. But there's also a rich research and scientific foundation for how do you apply the laws of thermodynamics to provide clean water to remote populations or clean energy. And you're seeing that come out through energy-water nexus, energy-water food nexus through the NSF, and other types of research-centric and research-focused agencies. In addition to that, there's the desire to grow the capacity or the competence for individuals to pursue and lead this work, both in terms of early career faculty, in terms of industries, but then also in terms of student attainment. And a report by the National Science Foundation that came out in 2008 called Educating Engineers as Global Citizens, a Call for Action. I'll quote this. There are urgent global problems, both short-term and long-term, that can and should be addressed by engineers, ideally engineers with global training. And so it's not just that there's a societal need for global good, there's a scientific goals to hit, but then there's also the stated need for we need to train the next generation of engineers to confront these challenges. And now you have a few dozen institutions across the United States pursuing humanitarian engineering and global development as specific degree programs. And if you think about where we are today, that's not too big of a departure from where sustainability was in the universities about 10 years ago. It was just at the cusp or that tipping point of there's leaders right in the field growing larger thereafter. So today's events highlight various types of projects that have an impact to society, a very specific research and scientific angle to them. They include involvement of local partners to take ideas all the way to implementation and monitoring and beyond for the purpose of delivering global good. And so as you're hearing and listening to the speakers today, try to learn and understand what their definition of impact is. How do they achieve that impact? Noting that the impact is not just to research publications, but then also to society delivering clean water, clean energy solutions around the world.